Chapter 5, number 9, you're going to solve each inequality, then graph it. Here we have the absolute value of x plus 3 is less than 18. All right, so we can now split this. So I'm going to split it into the positive equation first here, right? And this is going to be x plus 3 is less than 18. Nothing happens, the absolute value just breaks off. Then this is going to be the negative version. Be careful with the negative version. So you have x plus 3. Now, this is a negative 18, okay? However, the inequality also flips because it has the negative value here, right? Make sure you remember that. So this is how you split them, okay? We're going to subtract 3 to both sides. This cancels, leaving you with x is greater than negative 21. Same thing here on the second inequality. We subtract 3 to both sides. This cancels. X is less than 15. So this would be its answer. X is greater than negative 21 and x is less than 15. So when we draw the inequality, here is 0, here's negative 21, here is 15. It is open on 15 and it says x is less than 15. So it goes all the way to the left here. Then here it says x is greater than 21, so it's open here and it goes all the way to the right. Notice this is connected, so this is an AND. So you could technically write this as x is less than 15, which is greater than negative 21. That is how you could write the inequality. Okay, let's do B here. All right, so let's split it into its negative inequality and its positive inequality. The positive one is just x minus 4 less than or equal to 18. Okay, positive of course. Then the negative one is split into x minus 4, which is and negative 18. And remember, when you write the negative version of the inequality flips. All right, let's solve for x. So we're going to add 4 to both sides. This does cancel, leaving you with x is greater than or equal to negative 14. Here, add 4 to both sides. This cancels on the left-hand side, leaving you with x is less than or equal to 22. Now I draw my number line. I need the number 14, the number 0, and the number 22. X is less than or equal to 22, so it's closed, and it goes all the way to the left because it is less than 22. And then here, x is greater than or equal to 14. It's closed, goes all the way to the right. It's connected, so this is an AND inequality, so you can write this as x is less than or equal to 22, which is greater than or equal to negative 14, okay? That would be the inequality, compound inequality, all right? Let's take a look at C here. Before we split this, we have to get the absolute value by itself. So we're gonna add 9 to both sides. This does cancel, leaving you with just absolute value 5x plus 2. Close the absolute value is greater than or equal to 18 plus 9, which is 27. Now this allows us now then to split it into its positive and then its negative version, okay? The positive version is just 5x plus 2. The other one is also 5x plus 2, okay? This is 27, 27, okay? This one is a negative. This one is a positive. The inequality here is the same. This one is a negative version, so we flip the inequality, all right? So that's how it looks like when you break it apart, okay? Now let's solve. Subtract 2 to both sides. This cancels, leaving with a 5x is less than or equal to negative 29, right? Then divide by 5, divide by 5, you get x is less than or equal to negative 29 over 5. Because we're gonna have to graph it, let me see how it looks like. So this is equal to negative 5.8 in the calculator, okay? Let's do this one. Subtract 2 to both sides. This cancels, leaving with 5x is greater than 25. divide by 5, divide by 5, this cancels, x is greater than or equal to 5. Okay, this allows us to set up the number line. You need the number 0, the number 5, and the number negative 5.8 here. It is closed here at the negative 5.8, and it is closed here at also at the x. Notice here it says x is greater than 5, so that these are all the values that are greater than 5. Okay. And then here it says x is less than or equal to negative 5.8, so it goes all the way to the left because these are the numbers that are less than negative 5.8. So this is considered to be a OR equation here. Okay, notice y, right? Do you see how this is a greater than? Okay, this becomes an AND equation. Notice this is a greater than. This is also an AND equation. But take a look at this one. This is a less than. So it becomes an OR equation. All right. What about this one? This is a greater than. So this is also going to be an AND equation. Okay. We're going to see how that pops out. Right, so here we're going to get the absolute value by itself by adding 3 to both sides. This is going to cancel, leaving you with the absolute value of 3x plus 7 is less than 8 plus 3, it is 11, 8, 9, 10, 11, correct. This allows us to split this up into the positive value, then this into the negative value. So we have 3x plus 7, and we have 3x plus 7. We have the number 11 and the number 11. This one's going to be the positive version, so the inequality here stays the same. And then this is the negative version, so the inequality flips. All right, now let's solve and graph. So we're going to subtract 7 to both sides. Nothing happens to the inequality symbol. This cancels. 3x is greater than negative 18. Now we divide by 3, divide by 3. This cancels. X is just greater than negative 6. Okay, the inequality does not change. We dealt with a positive value here. All right, next one, same process, minus 7, minus 7. This is 3x. This cancels, leaving you with 3x less than 11 minus 7, which is a 4. Divide by 3, divide by 3. This cancels, leaving you with x is less than 4.4 divided by 3. 4 divided by 3 in a calculator is roughly 1.33, repeating, of course. All right, let's draw the number line here. We have the number negative 6, then we have 0, then we have 1.33. This is open at 1.33, and it is open at negative 6. All right, it says x is greater than negative 6, so these are all values that are greater than negative 6, right? Negative 5, negative 4, negative 3, negative 2, negative 1, 0, right? 1. X is less than 1.3, so it's everything less, right? 1.2, 1.1, 1, right? 0.9, right? This is an AND. Was I right? Yes, right? All the greatest symbols will produce an AND compound inequality. All right, so there you go.